Okay, so to continue where we left off in the first video, we were looking at a second way that we could have come up with the Maclaurin series for 6e to the negative x over 3. And that is, we could have started with e to the x, and we know what that is as a series, as an infinite series. And then we could have gone to e to the negative x over 3. And all we would have had to do then is to substitute negative x over 3 wherever we saw x in the original. And that would have looked something like this. It's exactly the same, except that wherever we had x before, we now have negative x over 3. And of course, simplifying that, we would have gotten 1 minus x over 3 plus x squared over 3 squared times 2 factorial, then minus x to the third over 3 cubed times 3 factorial, and leading us to the general term negative 1 to the n times x to the n over 3 to the n times n factorial. At which point all we would have to do is multiply by 6, and we would have had the same answer that we had above. Now, how do you know which one to use there? Well, the e to the x is not a difficult function to find higher level derivatives for. So the second derivative, third derivative, fourth derivative don't really change that much. If this were some kind of quotient and you'd have to continue to apply the quotient rule or the product rule again and again, then that would be prohibitive and it would take a lot more time. But in this case, it's really arbitrary which method you used. You could have come up with the same answer by either way, and I hope that's clear. You should be comfortable working with both ways so that as the situation presents itself, you'll know you'll have one or the other tool to use, and you'll obviously only need to use one of them for a particular problem. But then that would be the answer to A. I'll go on to part B in the next video.